Hi everyone, welcome back to my YouTube channel SK Tech. In today's video, we are going to discuss TreeSet in Java, and we are going to cover what is SortedSet interface, what is TreeSet, how to create the TreeSet, method of TreeSet, and how the TreeSet works internally with the help of some example. Okay, now let's begin. So let's first understand the hierarchy of the TreeSet. So TreeSet is nothing but one of the implemented class of the set interface, but TreeSet directly not implement the set interface. Internally, TreeSet has been extended by the SortedSet, and then SortedSet has been extended by the navigable set, and then this navigable set has been extended by, or you can say implemented by, the TreeSet. So TreeSet is going to bring the functionality of available inside the SortedSet, navigable set, and set. We will see what is the functionality available inside the SortedSet and navigable set. Okay. So first is like, let's say, what is SortedSet? So SortedSet is an interface extend the set interface as per the hierarchy. So it is going to provide all the functionality available inside the set interface. Along with that, it is also going to provide the functionality of the sorting. So internally it is going to provide the sorting functionality, okay, and that has been implemented by the TreeSet. We will see how the sorting functionality is provided by the SortedSet. And another point about the sorted interface is like, it is similar to the set interface only, but play a wider role to arrange the data in the ascending order, or you can say sorted manner. That's what the functionality of the sorted interface. Okay, and we know that the implementation class of the nothing but the TreeSet only. So these are some couple of the point that we have to understand. So if we want to create the object of the sorted interface, since it is an interface, we need the class, right? So we can create like this: SortedSet, then data type object equal to new TreeSet, because TreeSet is the implemented class of the SortedSet interface. So this is how we can create the object of the SortedSet. We will see with the help of the example also. So let's understand some key point about the TreeSet. So what are the key points that we have to know? So first is like ordering. So we know that TreeSet is internally extending the ordered set. It means that it is going to maintain the order. So order in the sense, it is going to arrange the element internally in the ascending order by default, but it also provides the functionality where we can store the element in a descending order. We will see that part also in the case of the example. Next is like uniqueness. So since TreeSet is internally implemented the set interface also, so as we know that set interface allow only the unique element, it does not allow to store the duplicate element. So in case of the TreeSet also, it is going to store only the unique element. Next point is like null elements. So since TreeSet is required to sort the element, or right, so it is required to provide the valid data only. So because of that, TreeSet does not allow to insert any null element. Next is like performance. So performance wise, TreeSet is quite slow as compared to the other set like hashset and linked hashset, because it is required to perform some extra operation like sorting, providing the navigation functionality also. So as compared to the hashset and linked hashset, TreeSet is slower. Next is like non-synchronized. So similar to the any other collection, TreeSet is also a non-synchronized. So if we want to use the TreeSet in the multi-threaded environment, then we need to convert it to the thread shape. So there are some couple of methods available inside the Java. We will be discussing that method as part of the thread concept. Okay. So next is like traversal. So since it is a non-synchronized, so if we want to traverse the element during the traversal is nothing but the iteration of the collection. So during the iteration of the collection, if we want to perform any operation that is going to modify the original list, so in that case it is going to throw some exception. So basically TreeSet is the fail fast. It means that during the iteration we cannot modify the structures, like during the iteration we cannot remove the element from the TreeSet, or we cannot update the element of the TreeSet, because if you try to update it during the iteration, it will throw some exception. That is nothing but the concurrent modification exception. Next important point that we have to know is like, it implement the navigable set. So it means that it is going to provide some navigation functionality also, like lower, floor, ceiling, higher. So if you want to get the highest element, if you want to get the lowest element, or near to the highest element or near to the lowest element. So there are couple of the method provided by the navigable set, that is nothing but the lower, floor, ceiling, higher, and for retrieval and removal of the first and last element also is possible inside the TreeSet, because these are the functionality provided by the navigable set, and this functionality is implemented by the TreeSet automatically because it's implementation of the navigable set also. So these are the functionality provided by the navigable set. So this functionality is going to be available inside the TreeSet also. So these are some couple of the key point about the TreeSet. Now let's see how we can create the TreeSet. So TreeSet is also provided some couple of the constructor, and using those constructor we will be able to create the object of the TreeSet. So first constructor is like the default constructor. So using the default constructor we will be able to create the object. Then we have another constructor called TreeSet as an argument of the comparator. So this constructor is helpful when we want to create the TreeSet and also we want to change the order of the element. Like we know that TreeSet is going to arrange the element in a ascending order by default, but let's say we want to change the ordering of the element, like we want to insert the element in a descending order. So TreeSet provide another constructor called this TreeSet ts equal to new TreeSet. Inside that we can provide the comparator. So comparator is nothing but one of the interface is going to provide the functionality of the ascending and descending order. We will see with the help of the example also. Next constructor provided by the TreeSet is like this. So let's say if we want to create the TreeSet object with the help of the existing collection, so in that case we can provide that collection as part of the argument. So here it will create the object of the TreeSet. Along with that, it's also going to initialize during the creation only what are the elements that we are passing as part of the argument. Okay, and next is like TreeSet equal to new TreeSet sorted set. So here let's say it will provide one of the another constructor where we can pass the sorted set interface also, so that we want to sort it or not, that is also we can control it. So these are the constructor provided by the TreeSet. Using that we can create the object of the TreeSet according to our need. We will see with the help of the example in a minute. But before that, let's try to understand what are the methods available inside the TreeSet. So as we know, TreeSet internally implements the set interface, sorted set interface, navigable set interface. So it means that what are the methods available inside those interfaces, those method is going to be available as part of the TreeSet also. And also we know that set interface is nothing but it is the extension of the collection interface. So all the methods available inside the collection interface, that method also going to be available. Like add, you want to add the element, we can go for the add all. If you want to insert the multiple value, like add all, clear, remove if, contains all, remove all. So as the name itself suggests the method, right? Add means we want to add the element, add all means we want to add the multiple element, we want to clear the element, we want to check any element available inside the TreeSet or not, then we can use the contains method. Contains all means similar to the content. If you want to check the multiple elements are present inside the TreeSet or not, then we can use this one. So I would recommend you to just pause the video and go through all these methods. So these are the methods available inside the TreeSet. Along with that, there are a couple of the methods available like poll first, poll last, split iterator. Split iterator is one of the feature of the Java 8. We will be discussing the functionality of the split iterator as part of the Java 8 discussion. And similar to that, these are some couple of the methods. So just pause the video and just go through this method. Now let's go to the IntelliJ IDE and try to understand or try to perform the some of couple of the operation. Okay, so let's say we have created like TreeSet class and we want to perform these are the operations like adding the element, updating the element, removing the element, iterating the element, and here we will check like what is the order that is going to be. So we know that as per the definition or as per the discussion, it is going to store the element in a ascending order. That is also we are going to verify. Then another operation that we want to perform like getting the size of the element, changing the order of the element as descending order. If it is by default is ascending order, let's say how we can change the default ordering. And then we are going to perform like how to store the custom class type. Okay, so now let's begin. So let's see how we can create the object of the TreeSet first. So first create the TreeSet object like using the default constructor. So TreeSet and then generic. Let's say what kinds of data that we want to insert. Let's try to insert some another generic like string, then ts equal to need TreeSet. So this is the one of the way we can create the object of the TreeSet. Now let's see how we can insert the element inside the TreeSet. So there is a method called add. Using that we will be able to insert the element inside the TreeSet. So let's see how we can do that. TreeSet add equal to. So if you see here, automatically it is suggesting like what kinds of data we can insert it, because we have provided the string type of the generic. So IntelliJ is detecting like we need to insert as a string type. So let's insert some value like skTech. Let's copy paste this one and insert some other value like learn Java by. Okay, so let's say these are the elements we have inserted it. Now let's see how can we print it. So before going to the next operation, let's see how we can print it. So let's use this simple statement like sysout statement and print this TreeSet. So this is the one way we can print the TreeSet collection, right? Now let's run the program and see the output first, in which order the element is inserting. So if you can observe here, the element we have inserted like skTech, learn, Java, by, right? But internally it has automatically sorted it in a ascending order. So if you can see, it is ascending order, like by will come first, then learn, then skTech, then Java. So in this way we can understand like by default it is going to sort the element in a ascending order. We will see how we can change the ascending order to descending order also. So there is one other constructor provided by the TreeSet. Using that we will be able to do that. Next operation that we want to perform inside the TreeSet is like we want to perform the update element. So first let's see, is there any method available inside the TreeSet that using that we can perform the add operation or not. So if you can see here, there is no method available inside the TreeSet. Using that we can perform the update operation. Then how we can do that? Basically you cannot perform the any update operation inside the TreeSet directly, but there is an alternate way. Using that we will be able to perform the update operation. And what is that way? So if you want to update any element, let's say we want to perform the update operation for the by. So first what you need to do, you need to perform the remove operation, something like this, ts.remove, and let's give the name like by, and again you need to insert it with the updated value. So using the add operation like by skTech 9521. So this is the alternate approach. Using that you will be able to perform the update operation. Now let's run this program, and before running that let's print this collection again, so that we will be able to see the updated record. Yeah, so if you can see here, by has been updated by the by skTech 9521. So this is the alternate way. Using that we will be able to perform the update operation, and also we have seen how we can remove the element using the remove method. Okay, now next operation that we want to perform is like iterate the element. How we can iterate the TreeSet? So using any of the for loop we will be able to iterate it. Even there is a iterator concept inside the collection. Using that also we will be able to iterate the element inside the TreeSet also. Let's try to use any of the loop like for each loop, and using that let's say how we can iterate it. So what is the syntax? Syntax is like we need to provide the object name here, I mean collection object name here, then colon, and what kinds of data it is going to return. So it is going to return as a string, because we have provided as a generic of the string. So it is going to return as a string type and some object here, and inside that we will be able to print it. Let's say we want to print it simply. So as, so let's write some statement here before performing the iterate operation. TreeSet iteration. Now let's run this program and see the output. Yeah, so if you can see here, it has printed all the element in a ascending order, because internally it is maintaining as a ascending order. Now we have also seen iteration of the TreeSet is like fail fast, right? So what do you mean by fail fast? So what we have discussed is like during the iteration, if we are trying to update, or if we are trying to modify the existing collection, then it is going to throw some exception. It is basically TreeSet is not going to allow the modify of the existing collection as part of the iteration process. So now let's try to test it here. Let's say during the iteration we want to perform some remove operation. So how we can do that? ts.remove. Okay, now let's try to remove the first element. And now let's run this program and see is it allowing or not. So if you run this program, you will see like it is going to throw some exception. So what are the exception? So we can see here it is throwing like concurrent modification exception. It means that during the iteration you cannot modify the existing collection. So since we are trying to remove the element, it means that it is going to modify the existing collection, and because of that it is throwing this exception, concurrent modification exception. Okay, so this is nothing but the fail fast. So if you want to make this collection as a fail safe, there is another methods available inside the collection hierarchy, that is nothing but to convert the existing list as a thread safe. Okay, that will be discussing as part of the thread concept. For now, let's remove this. Next operation that we want to perform is like how to get the size of the element. So there is a method called size itself. Let's try to use here. So TreeSet dot size, and let's try to add some statement here also, like size of TreeSet. Now let's run this program and see the output. Yeah, so if you can see here, it is printing the size of the element available inside the TreeSet, like that is nothing but the 4, 1, 2, 3, 4. Next operation that we want to perform is like how to change the order of the element stored inside the TreeSet. We have already seen if we are inserting the element, by default it is maintaining ascending order, right? Now let's say we want to change the order of the element stored inside the TreeSet from the ascending order to descending order. So there is another constructor provided by the TreeSet. Using that we will be able to create the object of the TreeSet, and also we will be able to change the ordering. So how we can do that? So let's try to create another TreeSet object here. Let's try to insert the integer type of data. Okay, this time, and let's give the name as a ts1 new TreeSet, and here we will be able to provide the another constructor that is going to tell the compiler that we want to insert the element in a descending order. That is nothing but the comparator. So using the comparator we will be able to tell in which order that we want to insert the element. Let's say we want to insert the element in a descending order. So there is a method called reverse order. So in this way it is going to create the object of the TreeSet, and also it is going to insert the element in a descending order by default. Let's try to insert some element here. Let's say we are to insert like 101 or 102, copy paste this element again and again, and let's try to insert some other element like 10, 50, 20. Okay, now let's try to print this element using this simple sysout statement like ts1, and let's add some statement also here for more visibility like ts1. Okay, now let's run this program and see the output. Yeah, so we can see here it is automatically maintaining the order as a descending order. So if we see the element 102, it is printing first, then 50, then 20, and then 10, but we have inserted 10 in the first place, right? So this is the way we will be able to tell to the compiler we want to insert the element in a descending order. So this is one of the another feature of the TreeSet. Using that we will be able to insert the element in a ascending order, and also we will be able to insert the element in a descending order. Now next operation that we want to perform is like we want to add the custom class type. Let's see how we can insert the element as a custom class type. So let's try to create a custom class type like consumer, and let's try to give some variable like, and let's try to create some variable like private int custom id string custom name. Okay, and let's try to create some constructor also here. So how we can do that? Using the generate method only, constructor, and we want to create the constructor of all type. Okay, now let's try to insert the consumer type object inside the TreeSet. Let's see how we can do that. So let's create one object like this, and now instead of providing the integer type, here we need to provide the custom type. Like we want to insert the element as a consumer type, so we need to provide here consumer. Okay, now let's remove this ordering part now, and now it will allow to insert the element as a consumer type. So how we can do that? Using the add method only. Now let's try to create some couple of the consumer type object. How you can do that? Simple, consumer c1 equal to new consumer, and here we will be able to provide the value like let's say int and string, right? So we can provide like 101 sktext, and let's say some other object also, learn java, give the different name here. Now let's see how we can do that. So let's add it here, and similar to that we will be able to add the c2 and c3. So easy, right? We will be able to insert the element of the custom type also, similar to the existing way. Like here we need to provide the basically generic type, like which kinds of data we want to store it. So instead of the built-in, we will be able to provide the custom type also, like consumer type in this case. So if you insert the element and if you print it, you will see something output like some hash code value, and why it is we will see. Now let's run this program and see the output. See, if you observe the output, it is throwing one exception, that is nothing but sktext dot consumer cannot be cast to the class of comparable. So comparable is nothing but one of the interface that is going to provide the sorting mechanism by default. Okay, and what are the type of the class that we are inserting here inside the tree set is not the implementation class of the comparable interface, and because of that tree set is not able to identify how to sort the element, because by default what are the element that we are storing it like integer type. So if you open this integer type class and if you see here, it is internally implementing the comparable interface, right? But our class is not implementing any comparable interface, and because of that if you are trying to insert the element, TreeSet is not able to identify what kinds of the data, how to sort the element, how to sort the consumer type object. So because of that, if you want to solve this problem, you need to implement the comparable type. So how can you implement the comparable type? Simply implements comparable interface, and since this is the interface, we need to override the abstract method available inside the comparable interface. So let's try to override it. How we can do that? Like this. So there is a method called compare to. This method basically is going to provide the sorting mechanism. So here we will be able to write our own logic on which way the consumer we want to sort it, either in the ascending order or descending order. Let's see, we just override the default way only. Now let's run this program again and see the output. So if you see here, now we are able to insert the element of the custom type, because this custom type we are implementing the comparable interface, and that is a mandatory if you want to insert the custom type inside the tree set, because tree set wants to know how to sort the element and comparable is the interface that is going to provide those sorting mechanism. Okay, now if you see here, it is printing hash code value. Why it is printing hash code? Because we are storing the some custom class type only, and that is nothing but the object type only we are storing it. So it is not able to identify in which way, in which format we want to insert the element. So to resolve this problem, we need to override simply toString method. So how we can do that? Simply go to the generate, override the toString. Okay, now run this program and see the output. Yeah, and now if you see here, it is able to print the value also in a proper format, but if you observe here, it is printing only one value. Why it is not printing all three value? Because it is trying to sort the value based on the implementation here. What are the implementation that we have provided? So we are saying that we want to return 0, means what are the element that you are printing. So for all the object, it is going to return the sorting value as a 0 only. It means it is going to treat all the value as a 1 value only. And because of that, since Java does not allow to insert the duplicate element inside the tree set, it is treating like all the element is a same types only, and because of that it is just inserting the first one, that is nothing but this one. So in this way we will be able to insert the custom class type also inside the tree set. So we just need to remember, like inside the tree set, what are the object that you are inserting, either the integer type, string type or custom type. All those classes should be implements the comparable interface, because TreeSet wants to know how to sort the element. So if you want to insert the custom class type, you need to implement the comparable interface, and also you need to override the compare to method. This compare to method is responsible for comparing the objects. Okay, so that's all for today's video. In next upcoming video, we are going to discuss differentiation between the different types of the collection. Like we have already seen list interface, set interface, queue interface. Now we will be seeing that what is the difference between them. We have already know the basic difference, but let's see in the detail. Okay, so stay tuned. We'll meet you soon. Thank you.